connected. Okay, so any other question for me, please? We have 3 more minutes, right? For those who are not on video, on camera. I see 2 people or few people, right? Mr. Jones or Sakisa, right? Please.
Yes, yes.
Please, can you? Okay, very good. Thank you. Okay, Mr. Fali wants to record. Who else? Mr. Jones, are you here?
I'm right here, sir.
Thank you. Okay. Okay. VI, which VI, please? VI, can you switch on your camera? VI, you okay? VI, okay. Why don't you put your name, VI? There's a lot of people here I cannot identify, right? So VI is Vivian, or whose name is this? I see a lot of V. I see a lot of name here. Okay. Anyways, NSOHC. I don't know how to pronounce it. Are you? Yeah.
Chair. He's in
Okay.
search. He's here. I think he's at work.
Yeah, I'm here. My laptop has a problem, so I can't connect with the laptop. I'm using my phone.
Okay. Okay. Thank you, guys. Thank you so much for the understanding. The only muted person is me on the second laptop on the other machine. Okay. I don't want to display the video twice. So, okay, good. Thanks. Okay. Now I can share my screen so that we can see. We can, Okay. Please, if you guys cannot hear me, let me know. Okay, Mr. Fali, I think I gave you the permission or not. Let me check, please. Maybe I did not. I thought I did. Let me see. Let me see that. Let me see the member.
I think I'm good. Thank you, sir. I'm good.
Yeah, good. Right.
Thank you.
Brian, permission for Brian.
Okay. It's just easy for me just to, you can just send me a quick text, a quick chat so that I can easily identify you, right?
Okay.
Yeah, way easier for me as well. Just identify you and grant you the permission. Okay.
Please, I have a question.
Yes,
it's a little out of topic, but I don't know. Our previous teacher, Emerald, she told us to download the Oracle Virtual Machine. I'm not sure what's the advantage of that. Can you please elaborate?
Oh, okay. If she advised you, it's because, the virtual machine, you are the one who have control over it, right? So it means that, like the type of maintenance issues with a virtual machine, you won't have it, right? It's a bit personal. So, and a virtual machine, you can make your own setup. You can configure as many virtual machines as you want. So it's like your personal server, your personal virtual server. Okay, so you can use it to navigate. And that is something I also had before. But since now I have a lot of environment where I can practice, I don't need that anymore. So that is something you will need, right, when you get to a real environment. Because at work, they may give you some tasks. Let's assume that it's your first time they ask you to perform a refresh or to perform something. You may go to your virtual machine and try it first. Okay, so virtual machine is just another environment you can create as well. Okay, that is quite different from the one you have now in Brontech to practice. Okay, so it's optional. It's important, right? But it's not really mandatory. Okay, not mandatory for us now. Okay, does it make sense?
Yeah, thank you.
No problem. So, but for a virtual machine, you need to make sure you have a good machine, a good laptop. Don't just think that any type of laptop will work with that. Okay, so for instance, you want to be able to set up a rack on the virtual machine, you need to make sure you have at least a 16 core laptop CPU. That means something quite expensive in order to support it, right? Otherwise, your laptop will be very slow. Will affect the performance of your entire laptop. So that's for those who want to try rack on a virtual machine, right? You need a lot of resources available. So yeah. Okay. Where am I? Okay. So now I can see multiple people at a time.
So I have a quick question, please.
Go ahead.
Okay, so I was just wondering if Arman backup files, we can call it database file.
Database file, yes, are part of the backup file, database file. When you talk about database file, backup file included. Yeah. It's included, yes, of course.
And what about the flashback file?
Flashback logs, yes.
The
included.
flashback logs. So what are examples of non-database file?
Alert log is non-database file. Alert log is out of the database.
Alert log.
The P file, SP file, P file, SP file are not in the database. The listener.ora, the network files, the trace files, the OG trail, the OG record, whatever you guys know that you cannot see from the database, when you are connected to the database, you can issue a command to see easily or to back it up, are non-database file. Okay, in a real environment, you may have some text files, some videos stored somewhere. Those are non-database file. Does it make sense?
Yes, sir. Thank you.
All right, welcome.
No, it doesn't, not for me. So you said that
Oh.
anything that when you go to the database, you can open it, it's not database file.
No, I'm not saying you can't open it, right? You can, an example, you can, for instance, back it up or identify a database level. Okay, it's another database file. Something you cannot back up, for instance, right? You guys should know database files. Data files are included, control files are included, video log files are included, archive logs files are included, okay? Backup files are included, right? So those are database related files.
Okay, so because the reason I asked that question, I was following one video, the guy on DB Genesis. So he made mention that it wasn't really clear that that Arman backup are not database files. So I wanted to verify.
Arman backup files. When you include data file, right? You talk about backup file included, part of it.
Yeah.
Yeah. Because you need that for recovery. To recover a database, you need that, right? You need a backup, right? That means if the database has an issue, you can that backup to reconstruct the database. Okay. So they are not data files, but part of the data. When you're talking about the database files, whatever is around the database, we include backup files. They are part of that.
Okay.
Yeah. Okay. So today, again, as I said, right, just an introduction, the topic, and I want us to live today, when we are living today, to understand what is rack, okay, how it works, okay, and what's the difference between rack and single instance, okay. Okay, so definitely what happened is that I want to take the architecture you guys are familiar with, right? So you guys are familiar with an architecture like this. A database server, that means you have an instance connecting to a storage, okay? So we should know something, right? We have two parts, okay? When you talk about an Oracle database, we have an instance and you have the database files or the database itself. The instance is what is made up of memory structures and background processes. And those memory structures include SGA and PGA. And SGA is what you have, right? Share pool, buffer cache, Verilog buffer, keep pool, Java pool, okay? That is what you guys are familiar with. And background processes, include PMON, SMON, check. Background, including foreground processes, right? And server processes, okay? You can include server process, PMON, checkpoint, all those processes you guys are familiar with. So all those processes and memories are located at the instance level. And at database level, you have the data file, the control file, backup files, archive log files, okay, and so on. So now, what is happening is that if someone wants to access the database, you have to go through the instance in order for you to be able to access the database, okay? So you cannot access the database directly. What do I mean by that? It means that if I have a user that is trying to get some data from the database, which is the storage, right? The user have to go through the instance, okay, in order for him or her to access the database. You can't access the database directly from your computer, okay? So the instance is the active part, okay? Is the what we call the memory, right? So you have to go through the instance. The instance is responsible to process your data, right? It make everything for you and return the result to you. So you get your data through the instance, and you receive and you write it. You write data to the disk through the instance. So you have to go through the instance for you to be able to have access to the database or to the storage. Okay. So that instance is basically what you guys identify at the operating system level. So whenever you guys are doing your PS minus EF grep PMON, that is what you guys identify. So it's what you guys see, and that is what is running there, right? Whenever you see it at the OS level, it means that the instance is running. It means that all the memory structures are available, and the processes are also up and running. That instance is also volatile, okay? So it means that in case of server issue, you will lose everything on that instance, from that instance, okay? So if the server crashes or hardware issue, right? And you have something that instance was up and running, the instance will also fail, okay? So it's not persistent as the database, okay? So I'll just take a short example with your laptop as well. Your laptop have, very two part, right? We have, the read-only part, that is the storage, right? The disk. And that's where you guys have enough space. If you guys check your laptop, you will see you have gigabytes. Some of you have terabytes of data. And you have another area in the laptop, that is the memory, okay? So that one now, that's what determines the speed of your laptop, okay? So you may have people have, dual, 4 gigabytes of memory. Some people will have 8, some people will have 16, some people 32, and so on. So the memory part is actually what, keeps the most recent copy of your data. So if you are able to open your laptop and you are able to see a document still on, it's because it was stored in the memory, okay? So the memory is the active part. But if you shut down, okay, you force the shutdown of the laptop, that means like a crash, right? You force the shutdown of the laptop and you try to start it back up, right? Normally most of the time, right, some document will be lost, okay? if they were not saved in the disk. Okay, so why am I bringing that, taking all those examples? Just to let you know, you guys know that you cannot access the disk directly at some point. Okay, you cannot access the data, retrieve the data directly from the disk. Whenever we are dealing with, regular servers, because you have database servers, you have storage servers. So the exception can happen on a different architecture called Exadata, that the GBA can access, the Exadata engineer can access the storage directly and do some operation there. Okay, so but regular servers, you guys or the application team access the database server first. That means they access the instance first, and from the instance they can get the data from the storage. Okay, so it means that if that instance is not available, you won't be able to access the database. That's what it's all about. Since you rely on the instance, right, you have to go through the instance to request some data, or you have to go through the instance to write data to the storage, right? It means that that instance is just basically, in the middle, somewhere in the middle between you or between the client and the database or the storage. Without the instance, the client won't be able to create a connection and connect to the database. Okay, so that is what the application team uses. They have to connect through the instance in order for them to retrieve the data from the database, or in order for them to write data to the database. So that instance is at the server level, or we can also call it database server level. So if anything happens to the instance, you won't have access to the storage. Now, what could be some operation that can affect an instance? Some operation or some activities that can affect, the availability of an instance. You can have a server crash. A server is a physical machine. It's like your computer, right? Your computer can fail. Those objects that constitute your machine will damage one day, right? They will not stay there forever. So, like servers, servers are a physical machine made up of physical components. So it means at some point they will get older and they will fail. So because of that, an instance can fail because of a server, right? A server issue. Okay. Server can cause an instance to fail. That means if my server is bad, something happened to the server, and I can, it will affect the instance. And if the instance is affected, it means that whoever is trying to connect to that instance will be affected as well. Whoever I call whoever by application team or any administrator. Okay. So the server failure or server issue can affect whoever is trying to connect. Okay. And also, let's assume that not just server, we talk about network as well, right? The network will not affect the instance, but the network can prevent you from accessing, an instance. Also, you may also have maintenance operation that can affect an instance. That means this operation can trigger you to bring an instance down. So you can find yourself shutting down an instance because you want to perform some maintenance activities. So let me take an example of some maintenance activities. It can be server-level maintenance activities or software or database level maintenance activities. Let me take an example of server-level maintenance activities. Okay. So whenever, for instance, at multiple times, that was not my job. Okay. Whenever, for instance, we noticed that we're having a lot of swapping. Okay. We said that, okay, they told me that I had to increase the swap space because our swap space was very small. And because of that, it was affecting our transaction on that server. Okay. So we had to increase the swap space. So by increasing the swap space, one of the steps for us was to shut down the server. reboot it basically. So if I have to reboot a server, it means I have to make sure that anything that is running on that server is down. So this maintenance activity I just performed is planned. Does it make sense? It is planned. It's not like it's unplanned, it's planned because we were facing some issues and we decided that we had to fix the issue by increasing the swap space. Okay? But the server has to go down. Okay? It has to go down. So that scenario, the instance will also go down, the listener has to go down. Anything that's running on that server should go down. What about the customer who are accessing the instance? That means they will have some outages, right? They will have some outage. They won't be able to perform their transaction or to run their code or whatever they are doing, correct? So it is affecting the availability of the system. It is affecting the service level agreement. Because for them, they are seeing an outage, right? They are seeing that the system is down. That's why sometimes you guys connect to website, they see in maintenance, or they put maybe 404, they put some errors, maintenance something. They are working on it. You are seeing an outage, right? Because you cannot access it. Behind the scene, they are doing something. They are working. Okay, so a maintenance activity can affect the availability of an instance, even though it is planned. But definitely it will affect the availability of the instance. Not just the swap space, anything else. If we have to, there are some parameters that to update at the OS level need the server to be rebooted. Kernel parameters. Kernel parameters, basically parameters, managed by sysadmin. Like you guys, Oracle database administrator, manage database parameters. Sysadmin manage kernel parameters. Okay, so some parameters, they also have configuration files. So you need to update those files, and some of them are static. Like you guys know static parameters and dynamic parameters. So some parameters require the server to be rebooted. So if the sysadmin is doing a maintenance activity, they may need to reboot the server. Does it make sense? In order for it to take effect. Okay, in order for it to be persistent. Okay, and some parameters are dynamic. You can change them without having to bounce the database. Okay, so those parameters that require the database to be bounced or the server to be bounced, the instance has to go down because you have to connect as root and reboot it. Some people can be doing deployment. Deployment is also another type of change that they can be running on the server. Let's take an example. If we have some alarm, okay, some alarm that are deployed on the server, and the alarm have a version. So if I deploy an alarm today, I may have a new version coming in, and I have to, if I want to update the latest one, I have to run the new one, right? To update the old one. And some alarm deployment require sometime the server to be bounced. Maybe you guys are not really understanding what I mean by alarm. What's an alarm? Let's take an example when it comes to a task, okay? How will I know that you completed the task? Otherwise, if I give you a task as a DBA, right, you cannot fix it. You will close the task, right? You will say, I close it. You not even fix it, but you just close it like that, okay? How will I know that you really resolve the issue? So we set up alarms so that till the alarm is, when you have the issue, you won't be able to close the ticket until the alarm turns green. The alarm is just there, just to validate that something is working fine. So if there is something wrong, like maybe the disk is 100% full, right? The alarm will be triggered. So that means till you resolve the disk issue, the alarm will be red. So if you are trying to close that ticket it will be open again. You reopen again because you haven't resolved the issue. So till you resolve the issue, now the alarm will turn green. And once it turns green, you can now close the ticket. That's an example. So it's just there to make sure that the issue is really resolved by the engineer. Okay. So some of the alarm now are deployed on servers. Okay. They are running on the servers. And sometimes they run some jobs, some pull requests to update those alarms. And some updates require the server to be rebooted in some scenario. So these are few examples among multiple that can, push you to reboot a server. And by rebooting the server, you also have to reboot you have to stop the instance. Now that is server level maintenance. Maybe it's planned, like what I just said, or unplanned if the server failed for any reason. Now, even at the database level or the software Oracle database level, you guys apply patches. And if you prepare, you remember, in order for you to call the OPatch utility, you have to make sure you shut down the listener, you shut down the instance. That means we have an outage. Even though it is planned, I know that I want to apply the patch, right? But I need to shut down my instance. Does it make sense? So in this scenario, my customer are still facing availability. They still have availability issues. I don't know if it makes sense. So for them, they don't care about whatever you are doing, right? They just know they have outage. So if they want to buy their shoe online, they want to do whatever they want to do online, they won't be able to do it till you bring the instance back up. That was a planned activity, right? But they have outage. Maybe it's unplanned. If it's unplanned and you don't have data guard set up, you will lose, right? They will still have outage. Unless you have data guard, you can now perform what you guys know, switch over or failover, so that they will not have a complete outage. Okay, so we guys see that some database maintenance activities or software level maintenance activities can affect the availability of the instance, right? It's the same thing that you guys want to increase the SGA, some parameters. Like if you want to decide that you want to increase the SGA max size, that one is a static parameter. The SGA target is dynamic, but the SGA max size is static. So if you decided that you have to increase it, at some point you have to bring down the instance and start it back up. That was a planned activity, right? You did it on purpose, but at some point the availability of the database will be affected. Okay, so you see that the instance can be impacted by multiple types of maintenance activities performed, either planned or unplanned. I also mentioned server failure, right? It's possible. User errors is possible, right? So it's possible for you to just kill an instance mistakenly like that at the OS level, right? And you kill it, you make it unavailable. Okay? So that's something I will not recommend you to do it, right? Unless you are asked to do it. I will never recommend you to kill an instance at the OS level because you are crashing the instance. Okay? So those are some downsides we have with a single instance. Whenever we are doing anything, maintenance, whatever, it affects the availability of the database. People cannot access it. But it also has some benefit though. It's easier to manage. That's what you guys have been doing. You just have to deal with one server, one database connected to one server. You just have to focus to that instance. Okay? Your GBA skills are focused only to one instance. You can monitor it. It's easier. The management is easier than what I'll be talking about. Okay? And also the license is cheaper than the other configuration I'll be talking about, which is RAG. So it works for a lot of people. As a GBA, you should be configured with single instance. It's mandatory, right? You should be comfortable with single instances. Okay. So now that I listed some downside of single instances, especially when it comes to maintenance activities or even plan on plan activities, let me now switch to something that is a bit different, right? Let me close this stuff. Also, let me close all this. I don't even want to make any confusion. Okay, so I will take everything from scratch. I don't want you guys to, I don't want to save it. I don't want to save it. I don't want to save it. Okay. So also, when I have one server, right? When I have one server, that server has a certain limited amount of CPU memory. It is true that we can scale up, we can increase. But when it also comes at the database or database level, the database have an instance have a set of processes, a limited set of processes that we can allocate. Okay. What do I mean by that? It means that the more the application is growing, more load we have in the instance. The load will increase on the instance. Okay, because if the application initially you have 5 people connecting to the application, right? It's like we are dealing with when a Facebook application, they just launched it. Let's assume they started with 50 people. Then we need a small database, right, to handle those connections. But when more people are coming, we need more resources to accommodate those connections because more people will be connecting to the instance. And if you don't, have enough resources or you don't have a good setup, you may deal with resource overhead or maybe, lack of resources at the database level or locking mechanism, right? Lock or wait event. So it means that whenever we have one system, whenever we have a single system, right? Everybody is accessing the same system. Sometimes it can cause high resource usage, right? The resource usage will increase. More resources will be used, okay? And the performance issues can also follow, okay? We deal with performance issues because more people we have, more resources will be used. And whenever more resources are used, can cause the performance overhead, right? Can affect some transactions, will affect other transactions from running, okay, optimally, right? So that means the overhead can also be an issue. The overhead would be an issue, right? Okay, high resource usage, because only that server is consolidating everything. Everyone is sharing the same server. Just by increasing the amount of resources on the server will not always fix the issue. Just by increasing the CPU on that server will not always fix the issue. Simply whenever I have multiple people going through the same server can affect the performance of that server. And also the network. When everyone is going through the same network, it can slow down the network speed. Okay, so whenever we are dealing with single servers, we may get into this type of issues. Okay, so and now let's take now that you have instead of having a single server like that, right? Single server, and people will rely on a single server or a single instance. How can I make this? Everyone is relying on a single instance. Okay. In case that instance, if that instance has some issues, okay, they will definitely they will have outages, right? So now we have another setup, right? that came to fix some of the issues we were facing on a single instance. And that setup is called real application cluster. Okay, so, and again, this is just the name Oracle chose to give to this type of setup. So you will encounter it, you will see it all over the places. They won't give the name rack, but it will be the same type of architecture. Even if you are working on Oracle or SQL Server or Postgres or in the cloud, you will face some stuff like that. They will not give the name rack, but they will give the name cluster or multiple other names. So you guys should, that means what? This concept is a general concept. So you guys have to understand the benefit of using this, okay? So, and now, unlike what the single instance was providing, that is at one instance connected to one database, now on Rack, we have 2 or more instances connected to one database. And I'll also throw more light on it later. Those instances are communicating as well. I'll talk about it later. Now, instance 1 is running on its own server, server 1, and instance 2 is running on server 2. Okay, so what do I mean by that? It means that on Rack, you have now more than one instance, fault tolerance. And each instance runs on its own server. It means that if instance 1 is running on student 100, instance 2 is not running on student 100 server, it's running on student 101 or another student server. Different servers. Okay, so that is the first thing you guys should know. So each instance is running on a different server. If I have 3 instances, they run on 3 different servers, separate server. Okay, but they communicate, and I'll throw more light on it. So now, what's the benefit of this setup? With this setup, if server 1 has an issue, people can access the database through server 2. Why? Because they share the same storage. What do I mean by sharing the same storage? It means that if I'm on instance 1, I can access the storage. If I'm on instance 2, I can access the same storage. So I can access the data either from instance 1 or from instance 2. So in case of any maintenance operation performed on this server 1, I can make a setup. I can create a setup, right? Such a way that whenever I'm shutting down this server, automatically everything that is running on this server will fail over to the surviving server or the next available server. I can set it up, and I'll show you how to set it up. It can be done automatically if you want it to, if you want to. Okay, so in that scenario, if the application was connected, this is the right place I was talking about services, right? So if the application was connected to this instance through a service 1, and I want to perform a maintenance operation on this server 1, I can just make sure that this service will be able to move to the next instance. And when this service moves to the next instance, my application user can access the database through the next instance. That is the high availability part of it. So you no longer have a dedicated instance for a particular database. You have multiple instances sharing the same database. one instance being down will automatically connections will move to the next available instance. Any maintenance performed on one of the server, connection can just move from that server to the next available server. So the downtime that we face is maybe just a transition, right? When the service is moving from one location to another one, that's where there will still some latency, or sometimes the transaction can be rolled back, but they will not have a connection error. The connection error, they will not have it with the latest racks starting from 11G release 2 onward. But before 11G release 2, they will have some errors that will be displayed to them, and I'll talk about it. What we have now. Okay, we no longer have a single point of failure, right? In case one is not available, connection, your user can access the database through another one. So if I want to patch Oracle software that is on server 1, I can just redirect the services to server 2 and I patch it. When I'm done here on server 1, I move to server 2, I patch server 2. When I'm patching server 2, the connection will move to server 1. That's already patched. That one also depends on the type of patching I want to perform, because you may still decide to patch both at the same time. That is just an example, right? But now you have at least, right, the availability part, okay, is met, right? Because you can decide that you don't want, you want now the database to be available. You don't want it to be down for a long period of time due to hardware failure, okay, or planned downtime or unplanned downtime. Does it make sense what I just said or not?
Yes, it does.
A little bit. Makes sense a little bit.
Yeah, a little bit.
Any question? Just ask the question you have. Any doubt? Just ask. I'm here.
Mr. Gata, you say Oracle hack the more instance connected to one database. If you got issue for instance maybe one, and you can set up the command to switch over to instance 2. But if you got problem in the database level, why you go resolve the problem?
Okay. At the database level, rack. Okay. Very good question. Very good question. Talk about instance 1. At the database level, I will talk about a component called ASM. Okay. I don't want to talk about it now, but I'll talk about it. And that ASM can help you, to also ensure high availability at the storage level. What do I mean by that? The ASM can help you to have multiple copies of the data in the storage, so that if one copy is lost, I can get the other copy. If I have corruption, one block is corrupted, okay, somewhere, we can access through the duplicated copy you have. Okay, copy of data with the storage we talk about. Okay, and also that storage manager we talk about is a smart manager, because it knows how to organize the data at the storage level. If I have a corruption or I have a disk that is corrupted, that manager will automatically remove that corrupted disk from the environment so that it will not affect other disks. Okay, so at the instance level, there is someone who is there to monitor it, and also at the storage level, there's also a component that is there to monitor it, to make sure that the availability is met at the storage level as well. Okay, so I'll talk about it today. That is the ASM. I will just introduce it, right? But I will throw more light on it on the upcoming PowerPoint.
Just almost a little question. How many instances in Oracle can connect to the database? I mean, you don't have the limit.
Multiple. You may have a limit depending on the version, okay? So you can look online, okay? I want to never pay attention to that because you hardly see companies going to a certain amount of instances, right? So you have it's more than 30 and above, more, as many as you want, right? You can have it, okay? So, but you know, the more instances you have, that means the bigger database you need. Does it make sense?
Yeah.
That's
Yeah.
part of the planning phase. Yeah.
Thank
Google,
you.
right? You can Google. If Google is open, you can just check the limit, and maybe Google will provide you some information. Okay.
Thank you, Pusher.
All right. You're welcome. Any question?
Mr. Gaetan,
Yes.
I have a quick question, but not regarding this. I just wanted to find out if Oracle is a database or a software.
Oracle is a company. You understand what I'm saying?
Could you show more light?
Oracle is a company. Oracle Corporation is a company. The name of the company is Oracle.
Okay.
Now Oracle have products. Among the products, we have applications, we have software, right? All those, a lot of products they have. So now one of the products is the Oracle software. And on top of an Oracle software, you can create an Oracle database. The Oracle is just the name, just to differentiate with other type of databases that exist.
Mm-hmm.
You see SQL Server databases, Postgres databases. That is just a way how we can differentiate. But Oracle itself is the company. All its products, you have its name somewhere around. Does it make sense?
Okay, sir. Yeah, that makes sense.
Good.
Okay.
Any question? Okay. Okay. So definitely, this is one of the biggest benefit. Okay, we have by dealing with RAC. Okay, because now we have the availability part. If one server is not available, you can access the database through another server. And let's even go further. When it comes to resource usage, right? Now I have two servers. It means that those two servers will provide more resources than just if you were using only one server, correct? The previous configuration, which is single instance, we had only one server, okay? And one server comes with its own CPU, its own memory, right? And its own swap space, and also, its own set of processes. So by having two servers, it's like you have now you have two hands, right? You multiply the number of resources provided by the previous servers by 2. So if with a single instance, right, the server was providing, 100 gigabyte of memory. Now with the rack, it will be 100 times 2. I mean, twice the amount of memory we had available. Okay, sorry, I muted the wrong person. Okay, so that'll be quite twice the amount of memory, okay, you had available if you were using a single instance. So having more servers will definitely help, to receive more connections or to speed up transactions. Okay, and that's also valid for databases. Now you have two instances. It means that if each instance if the initial one, single instance, right? The instance, okay, had maybe 1 gigabyte of memory. And now you have two instances. It makes 1 gigabyte times 2. That means you have twice the amount of resources you had only on a single instance. It means that transaction will take, okay, you can take advantage of more resources provided by Oracle. So definitely the rack environment can also help you when it comes to resources. Having more resources available can definitely improve the performance of the system. And it can also reduce concurrencies. Because if you have multiple people, okay, sharing one instance, and now you can split transaction. That means you can say, okay, I want some people here, and I also want some people here. Then I can divide the load. I can split the load. So one set of connection can access instance one set can access instance 2. It definitely helps me because all of them are not just consolidated on one instance. Okay, so that is another benefit, right? Reduces, improve, okay, the performance of the system, and it helps you to, easily manage resources.
Mr. Gaita, I have a question.
Yes.
So since it can have many instances, is there any instance where the DB writer write first?
The DB writer is at the instance level. That's why I started talking about memory structure and processes.
Oh, okay.
The DB writer is dedicated to each instance, correct? An instance has its own set of memory structure and background processes.
Okay.
Correct? So that means instance 1 has its own DB writers, and instance 2 has its own DB writers.
Okay.
I don't know if it makes sense.
It does.
The DB writers is an instance level process. So each instance has its own DB writer. Each instance has its own PMON. Each instance has its own SMON, its own checkpoint process, its own SGA, its own PGA, its own buffer cache, and so on, right? That's why I started with the architecture. To show you that the rack, you are just multiplying based on the number. Okay, you have 2 node rack, that means you have twice the number of memory and so on. Makes sense or not?
It does.
Mr. Gaita,
Okay. Yes.
you also said this architecture also allows big swapping. So
Who said that?
oh, I thought you made mention about swapping.
No. Swapping was far behind, right? When I was talking about maintenance activities that can affect an instance. Maintenance activities that can affect an instance on a server. Swapping is whenever the swap space is getting used.
Mm-hmm.
And swapping means the server has to go to the disk in order to grab from memory, okay, to run. Now, if swap space is highly used, it means that the performance of the system will be affected. And I said that in my environment, I had to increase the swap space in order to reduce swapping in our environment, to reduce swapping. And now, in order for me to complete the operation, I had to reboot the server. And if I want to reboot the server, it means that I have to shut down everything that's running on top of that server. That's why I said that you will need to shut down the instance. So it is a single instance database. It means that the only instance has to be down. Where will the application team connect to? They won't be able to connect to the database, right? Because that only instance has been brought down. I don't know if you understand the context, because that's when I start talking about swapping, just when I was talking about maintenance activities.
Right. All right. Thank you.
Okay, you're welcome. Any question? Any question?
Hey, Gaetan.
Yes.
It's not a question, but just to let you know that I cannot see the presentation on my laptop, so I switch to cell phone.
Can you guys see my Paint document? The Paint?
Yes, I can see the pen, but I cannot see anything else.
No, that's fine. I did not display anything else.
No, this one let you know because I'm on my phone with a different name.
You see what, please?
I'm using my phone and I turn off my camera on my laptop. Just want to let you know so you don't see a different name and then.
Oh, okay. Thanks for letting me know. Yeah.
Okay.
And I noticed some people turn on their camera, please. Okay, so.
So I have a question.
Yes, please.
I want to ask if there's any occasion where server 1 and server 2 can be affected.
It's hardware, right? It can happen. It can happen.
So
hardware failure.
That's
hardware failure, right? It can happen. Since they are next to each other, it's different from data guard, right? Data guard, when I was talking about standby, I was saying that they are at a different geographical location. Okay, so that means if for rack, those servers are next to each other because they have to be connected by cables, network cables, in order to communicate. I will talk about those cables. How do we call them? So they have to be connected, interconnected, so that instance 1 can talk to instance 2 and vice versa. So they are in the same room. So if, for instance, I have a natural disaster on that data center in that region, right? Then both servers can be affected. Does it make sense? If I have anything that happened, a war or anything that happened in that particular location, can affect both servers at the same time because they are there at the same physical location. Does it make sense?
So probably so what could affect them is like a network problem.
Network do not cause the server to fail. Network may prevent you from connecting, right? You may not be, maybe you won't be able to connect because you have to go through the network to access the server. Okay, so the network can prevent you from connecting to the server, not stop the server. The server should not be down because of network. Does it make sense?
Yes, sir.
So, sir, so is the switch over, is that automatic or is it manual? Like if there's a crash on
definitely you can set it automatic as well. That's why I'll be talking about services, and I will throw more light on services here in this particular topic. Because what we call services, and that is what application team will use to connect. Application user never use, I don't know, maybe some few environments we have that exception. Application users always use services to connect. So a service will help you to connect. So you can set up what we call automatic failover. So that those services can dynamically move from one instance to another one in case this instance is no longer available. Okay. And I will call it transparent application failover when we get there. Okay, so you can set it automatically, and we will do that together. I will do a setup like that, and we will trigger a crash, and you will see how the service will move from one instance to another one. Okay.
Question, please.
Okay.
Yes.
What if the situation where all instances fail?
Yes, it can happen. Yes,
yeah.
Proceed. That's your question, or you have more to say?
Yeah, I just say like, what if the situation where like all instances fail and there's no one to switch to the next, like all of them fail at the same time or something happens like that? What happens?
Definitely, you won't be able to connect, right? Because there is no backup instance. But if you have data guard connected to rack, you can do that. Because rack is different from data guard. You can set up data guard on rack. What do I mean by that? It means that you have rack, but you have a standby of rack somewhere else. That means what? Rack, for instance, right, let's take an example. You have 2 nodes, 2 instances, and the standby also have 2 instances. That means the primary is a rack and the standby is a rack environment. So in that scenario, if all the instances are not reachable, you will have the failover to the standby, what you guys learn on data guard. And if it makes sense, if you have data guard, if you don't have data guard, enable then outage. Nobody will be able to connect. You have to fix it.
And 4 of the instances should be in sync, sir.
What do you mean by it's in sync?
Because one database have 2 instances and they're communicating, right?
Mm-hmm.
And on the other server we have the same. 4 of the, I mean, they're gonna be in sync, right?
But the synchronization will just be, you know, it doesn't mean that instance 1 will have the exact data as instance 1 on the standby, okay? You just have to make sure that the setup, data guard setup is good. So there's no synchronization. You guys know that the database on the source should be the same as on the target. Does it make sense?
Yeah.
But the instance level is different. So there's just a database level that should be similar. So
Okay.
if I have this amount of data here, it should be the same amount of data on the standby. That's the only thing I need.
Okay.
Does it make sense?
Yes, sir.
Yep.
Sir,
Yes.
so this rack, the server down here I'm seeing is like a big server, which is probably different from ours, from the regular one. And the instances up here, they are like memory that exists on the server.
No.
I'm trying to get
Yes. A server comes with its own amount of memory, CPU, and a certain amount of swap space you can map from there. Okay. And sometimes the disk, the storage as well. A server is made up of all that, the memory part and the disk part. So the instance comes into place whenever you are installing the software. You will never have an instance running on a server if you don't install Oracle software. I don't know if it makes sense. When you guys were installing Oracle 11G, it's after you install Oracle 11G and you went to DBCA, you created a database, it's right after that time you were able to see an instance running, correct?
Correct.
Sir?
It doesn't have anything to do with a server. On top of a server, you have some other stuff that can run on top of a server than a database. You have an application that's deployed on a server. Whenever you guys are hearing about, you know, e-commerce application, PeopleSoft, whatever, those applications are also running on top of some servers. But they are just connected to another to a database running on a different server. And they know how to communicate. So they are different. An instance is different from a server. A server, physical machine, that comes with a certain amount of resources available. It's a limited amount of memory, certain amount of CPU, certain amount of disks, and so on. That's what it comes. That's how, so when someone is selling you a server, right, a machine, it comes with all those stuff. And now the instance, especially Oracle instance, comes into place after you install an Oracle software. That's when you will have an Oracle instance. When you install an Oracle software and you create an Oracle database, it's after that time you will have an instance. But before that, you will never see an instance on a server. Are you getting it, Mr. Koji? Or not?
I'm trying to relate to what you're saying.
Okay, try to digest it.
It will take a while, but I'm good. I'm good.
So I was just wondering, is there any disadvantage or something that the end user might face when maybe server 1 goes down. So like maybe if they're performing a transaction, it's going to fail. So they'll have to do it all over again.
Correct. Yes, that is one of the advantages, especially when you are doing a GML operation. And it also depends on the type of failover you configure. Okay. When we get to that level, I will talk about just ahead of the time now. Please don't take it, don't get confused. I will talk about transferring application failover at the client level and at the server level. So you will set up the failover at the client level and at the server level. Now, it will depend on the type of failover you are setting up. If you set up, some basic, a type of failover that is like, for instance, select. There's a type of failover called select. It means that all the select operation, if the person was running a select operation on the instance 1, and instance 1 fails, the person will be able to get the result from instance 2. You don't have to run the select again. Okay? But if it's not select, it's another one, and you run a GML, it will hold it back, okay? You will need to run a GML again on instance 2. So at some point, you may need to run again a transaction in case there's a failure from instance 1 to instance 2, especially when you are not dealing with select operation. But if you are doing GML, it will hold it back. If it was not committed, right? If you were just performing a GML on instance 1 and you never committed it, okay? Once you are switched to instance 2, you have to run it again a GML. But if the transaction was already committed, the redo was already generated, right? And written to the disk, you won't need to run it again because it's already registered to the storage. I don't know if it makes sense.
Yes.
If it doesn't make sense, you guys should let me know.
Yeah, please, if you can just take it back again.
Gata, can you explain one more time?
Yes. What I was saying is that in RAP, we have multiple types of failover. And again, right, application connects to databases using database services. And I will talk about database services again. Later, I have a PowerPoint on that, a slide on that. So those services are actually what allows the application user to take advantage of instance resources. Now, let's assume the application user, the type of failover, because you decide the type of failover, we do it. If the type of failover you choose is select, what do I mean by that? It means that on instance 1, you perform select star from scott.emp. And after you issue that command, the instance crashes for any reason, right? That service will be redirected to instance 2, right? Because that's what we want it to be. That's how we want it to be. If one instance fails, connection will move to the second instance. So if the type of failover was a select failover, it means that when those connections will move to instance 2, they won't need to issue the same select statement again. They will just get the result straight from instance 2. You won't need to issue the same select star from scott.emp again on instance 2, because the type of failover is, for instance, select. Okay? But now, if you have another type of failover, select, okay? The name is somewhere there. It's not select. I will find it somewhere here. To give you the right exact word. If it's session, it means you will move to the next instance and you will recreate a new session. A new session will be recreated from a new instance, but you may need to run a transaction again. Okay, so your session will just be recreated on a new instance. But whatever you were performing on the previous instance, if that was not committed, that will be rolled back. And on the new instance, you will need to run the command again. Okay? So, and that's also valid for transactions. Okay? And that's basically if a transaction was running on one instance and that instance crashes, the transaction will keep on running on the second instance. It won't be stopped. Okay, so we'll talk about this one later on. Okay, so I just wanted to answer the question, the lady's question regarding, whether transaction will be rolled back. Yes, some GML will be rolled back if they were not committed, but if they were committed, they won't be rolled back. Okay, when you move to the next instance, you don't need to issue the GML again because the database already registered the redo information. Make sense or not?
Yeah, it makes sense.
We get there, we talk about it again, okay? Just going ahead of the topic, but I will talk about transparent application failover again. That is a bit advanced. Okay? When we get there, we talk about it and we practice that.
So I was just wondering, so how about those like bad jobs? If some include like the select statements and some include like the sessions. So how is that going to work? Because like if they follow each other, and then in between there is a crash. So that means the whole job is going to fail.
You say you have a job.
Yeah.
The job includes what? Select statement and what?
And then the other type, like different types of statements.
No. What do you mean by different type of statement? Select and GML includes
and
select statement
GML.
and GML operation on
Yes.
the job. Again, right? Depending on the failover, the type of failover is okay. If you are dealing with failover type equal session, the select won't be, you won't get the feedback of the select again on the target side on the second instance. Okay, but the goal is just that session will be recreated again on the second instance. Just a session will be recreated. So you choose sessions, it will be recreated on the second instance. Okay. Now, what happens is that the job will be recreated, it will fail. So you may need to run again the job. You run it again. Does it make sense? It won't resume automatically unless you choose continuity transaction. So if the transaction was actually running, you don't want it to fail, right? So whenever it's switching to the next instance, you want it to keep on, okay, to work. You don't want it to fail, you want it to run, even after the failover. So each of those configurations depends on the type of failover you choose. For select, you may not need to run the select statement twice. For session, the session will be recreated, but you may need to run again, especially if the transaction was not committed. And for transaction, the transaction will have application continuity, so they will not have downtime. Transaction will keep on running on instance 2. Okay? So that's basically how they work, okay? Another question? Are we sleeping? I'm seeing a lot of people offline. What's going on? Can we turn on our camera, please?
What did you say, Gaetan?
I'm seeing a lot of people offline. So if they can turn on their camera. Who is even sleeping?
Patrick is sleeping.
No, I'm here.
I did doing roll call. Sorry, I was not.
Okay. So that's even why I said that it's difficult, right, to keep track of people when there's no video. Right? Someone even display his bed. So maybe the person is sleeping, right? So, okay. So now I will move to the slide, the PowerPoint. I just wanted you guys to, okay, I will not maybe add a small detail on what I just explained on this rack architecture. Let's not forget that as the application grows, the workload also increases. Okay, so it means that if I need more instances, that means I have 2 instances, for instance, right? I have 2 instances, and I notice that the application is growing in size and more resources are needed. So with Rack, I can dynamically add another node, instance 3, on server 3 without, I can add another node online. So that means while the database is running, the services are running, I can dynamically add another service, another node or another instance to the Rack environment. Or if I see that a lot of resource, I'm not using these resources efficiently, I can remove extra node I have. Let's assume I have 4 nodes, okay? 4 nodes Rack, and maybe I'm losing customers. Maybe my business is going down, right? Very bad experience. And I have less people accessing my database. What will I do with those 4 nodes, right? I can just remove one of the nodes and stay with 3 nodes, or remove 2, depending on the workload. So you can see that dynamically with Rack, you can scale up or scale down. That is what we call scalability part of Rack. You can add nodes if you need more, or you can remove nodes when you feel like you don't need them. You don't need it. And that is done dynamically. It means that the service is not affected. The application is not affected at all. There is no downtime needed. Make sense? Okay, so that was the addition I wanted to provide. So now let's switch to PowerPoint. Okay.
So, quick question.
Yes, Mr. Koji.
What which, I don't know how I can say it, but what is the put? Are you the one that's going to administer memory to those nodes, like space?
What happened is that in Rack we're talking about disk. This storage is made up of disk.
Okay.
And those disks will be made available by the sysadmin or project. So when you guys be setting up Rack, you'll be running some command, some script to create this disk, to make them available and use them for the storage. That makes sense? So you need some disks available in order for you to create the storage. And those disks are made available by the sysadmin. Is the one to make all those disks available, and you can use them to create the storage, or to create what we call disk group. That is something we talk about when we get to ASM. Okay?
Okay.
Yeah. Okay, so okay, so so whatever I said right so far is found here. Okay. So I talk about high availability. The high availability part, is met, because you have more than one instance. And in case one instance is not available, I can access the database through another instance, right? That's the high availability part. Okay. So it can help prevent, planned and unplanned downtime. Does it make sense? And also the scalability part is whenever you are adding more node, right? If you need more instances, you can dynamically add more instances, or you can remove instances if you don't need them. Does it make sense? So we have what we call vertical scalability and horizontal scalability. So vertical scalability, you can decide to increase CPU for each node, and horizontal scalability means you can increase servers, okay? That means you can add more servers, okay? So that is what racks can provide. Scalability, add more resources or remove resources. That is what the cloud provider actually perform, okay? Because that is one of the biggest issues we have on a single instance configuration. Because sometimes you may have a server, but you don't even use all the resources, okay, on that server. That's what makes the cloud very important. That's why people are moving there, because you can use what you need, okay? I don't talk about it, but this was just an occasion for me to just throw that, emphasize that detail. So that's the scalability part. You can add more instances or remove, or remove instances if you don't need them, okay? Or you can increase CPU or reduce the CPU if you don't need it. And the load balancing part, okay, I talk about two instances, right? Instance 1, instance 2. We can have more. In rack, we don't want one instance to have more load than the other instance. We want the balance, right? You want to balance connection, you want to balance the load. So it means that rack can ensure the load balancing. So if a connection is trying to come to if for instance, right, I have a connection that is trying to go to instance 1, and instance 1 is more loaded than instance 2, rack is able to redirect that connection to the least loaded node or the least loaded instance. So it ensures load balancing, making sure that one instance is not more loaded than the other instance. They have almost the same load. Does it make sense? So, and that's what you guys see, load balancing, okay? Balances the load across instances. Also at the storage level, when we get there, I talk about disk. I talk about disk group and disk. And I will tell you guys that the ASM will make sure that each disk on the disk group have the same size or have the same amount of data. That is also part of the load balancing, okay? And that scenario I will talk about striping, okay? And we get there, okay? And also resource utilization, you have more resources available because instead of having only one server hosting one instance, you have 2 or more servers hosting multiple instances. So it means you have multiple servers doing the job for you. Hack also have some drawbacks, right? And the biggest drawback is the cost, okay? The license is more expensive. So you need a rack license. You want to use rack, you need a license. It's quite expensive as well, okay? So, and the hardware and the component, it's a bit complicated, a bit more complicated than what you guys are familiar with. So you guys may need to learn new terms, right? And you may need to learn new component and how they work. So when it comes to the architecture, it's a bit different from what you guys know already. So you need to learn something new. And the third point is that rack is not designed for disaster recovery. So never replace rack with data guard. Never replace data guard with rack. Never say that rack is better than data guard or data guard is better than rack. They are used for different purposes. If you want high availability, server failure, you want to prevent server failure, rack is the best. In case the server is not available, connection can go to the next server. But if you want to prevent, again, site failure, a site failure, that means an area, right? If the area fails, data guard is the best, because if an entire CT fails and you have a standby somewhere else, you can access your data, right, through the standby. So that means one is specialized on hardware failure. That means whenever you are dealing with server failure, rack is the best. But when you are dealing with site failure, Datacard is the best. So don't mix them. So you cannot use rack for disaster recovery. For natural disaster. Does it make sense? You can't. It's not meant for that. And rack is a bit more complicated than the single instance. Again, for the GBA, you have to learn new command. You have to know to learn new log files. In addition to the other log you guys know, there are some other files you guys may need to learn. You guys may need to learn the log messages, the CRS logs, the CSS logs, the event manager logs, and so on. Multiple other log files involved. Not just log file, right? New tools involved. CRS CTL, SRV CTL, ASM CMG, ASM CA, and so on. So it's a bit more complex than what you are familiar with. Okay? And now, the formula is very simple. Why will a company decide to use rack? Let me tell you guys that because rack is expensive, Oracle provides another solution called Rack One Node. If you don't have money to buy the full rack license, you can buy a Rack One Node license. So Rack One Node is basically a rack environment with 2 instances only, but one instance is active at the time. The other one is not active. So the other one is there, will become active only if the first instance fails. So that one is just there in parentheses as a standby instance. It's not replacing Datacard, right? But it's just there as a standby instance. So if the first instance fails, automatically the second instance will be enabled. Okay? And also, if you want to perform maintenance activities, you can also do that dynamically. So it has limited, benefit simply because you cannot use 2 instances at a time. You can use only one. Okay? But apart from that, you can still take advantage of high availability, okay, and scalability. You can decide to convert when you have more money, when your company has more money, to switch from Rack One Node to Rack itself. But it's different license, right? You can do that without having to shut down the database dynamically. Or if your business is falling, you can switch from a Rack to a Rack One Node. So Oracle provides Rack One Node option, okay? For those who don't have a lot of money to buy a Rack license.
So I have a question. So with Rack One Node, if one database is down and the other one takes over, does it, is there going to be any downtime?
No.
Okay.
As well. Okay? No
Okay.
downtime. Yeah. But you can't take advantage of both at the same time, one at a time. The other one is just there to wait when the first one is not available. Does it make sense?
Oh, so both of them can work at the same time?
No, they can't work at the same. They can't work at the same time. That's
Okay.
Rack One Node. Mm-hmm.
Okay.
So how
Okay.
that the second instance is having the same information as is the second instance having the same information as the first one, sir?
Not necessarily, but because they have the same storage, they
Okay.
have a shared storage. That means if I even switch to instance 2, I can still access the same data.
Okay.
Does it make sense? Yeah.
And
That's how it works.
and they're
It doesn't mean
still
that instance the duplicate of instance one. No, it's not a duplicate. Okay, just there as a standby instance. Yes, go ahead. Your question, Anita.
So and they're still on like different servers too, right?
Yes, different server.
Okay.
Will there be any data loss?
No data loss unless the transaction, you know, if you did not commit your transaction, right? Okay, you guys know when you run a GML, in order for it to be, you know, to be stored in the database, it has to be committed, right?
Yeah.
If it's not committed, there will be a whole back. That means definitely you will lose it. Does that make sense? So the data loss will come into place in case you have a server, okay, the server crashed, and uncommitted transaction will just be rolled back. But all the committed one, because the redo was already generated, they won't be lost.
Okay.
Okay. Yes, you can have data loss at that level. Okay, not nowhere else. And with RAG is still not preventing us from performing our regular backups. Does it make sense? So our backup is still there. Our backup strategy is still there. Arman backup is still there. Maybe we have, if also take the, maybe you have the chance to perform backup on RAG. Okay, so you can still take your backups, you know, for maybe recovery purpose or maybe for cloning or refresh. Does it make sense? But RAG is just there for availability as well. It also enhances the availability of the system in case of server failure. Question?
Sir, when
Yes.
when I was in DB2, I really can't remember the last time, especially when I was taking the exam, I really can't remember the last time I issued commit. But I found out that all my data were registered and they were in the database. So does it like Oracle manage automatically or what?
What do you mean by the data were registered? What data?
No, because he said it wouldn't be registered, it won't be stored in the redo logs, right? But I didn't, like you said, if I didn't commit, then it wouldn't be registered in the redo logs.
You guys learn instance recovery, right? When an instance crashes and you try to start up an instance, right? How the recovery process works. You guys never learned it? I'm sure Mr. Brendan taught you guys that. Prof. Instance recovery, that is GB1 or GB2. I think he said that if I have an instance running and on that instance we had both committed and uncommitted transaction, right? Because the GB writer writes it in batches. So that means not because you just committed a transaction just means that automatically it's already written to the disk. You can commit a transaction, but it's still in the memory because the GB writer is waiting for a group of commit in order to write to the disk, right? So on the instance, we have both committed and uncommitted transactions. Now, whenever an instance crashes, you are trying to start it to bring it back up. The XMON process will be the one to bring back all the data to the memory, hold forward whatever was committed, and hold back whatever was uncommitted. You guys never heard of that one?
We heard of it.
Okay, that is how it works. So if you are saying that you never observe what, data loss or what?
I said I didn't issue commit, but all my data was there. I'm sure they were in the redo logs.
No, they could be there, but once you exit, you come back. Oracle will remove this stuff. Do you exit? Do you close your session? You came back and the data was still changed? Because if you update code.emp, you change the salary. If you don't commit, you close your session. You think you will come back, you will find the same value? Oracle will hold it back, right? Because you closed your session already. You exited. So you issue commit, then Oracle will register it to, the checkpoint will take place and the log writer will write it to the disk and so on.
Okay.
Mhm. It's like a Word document. If you are working on a Word document, you are typing down, typing, till you save it. You don't save it. You can be lucky, right? Because your session is not closed. You leave your laptop open. You go, you come back. It's there. But if you force a shutdown of your computer, you start it back up. You will lose everything that was not saved on that Word document. That's the same thing with Oracle with the blocks. Okay, so it's applicable as well. Okay. Anything else? All right. So here we are with the typical architecture of rack. I will not talk about this architecture. Is a non-flex architecture. Non-flex architecture, because I will talk about flex cluster and flex ASM later. Those are 12C related. On 12C and onward, you can decide to have a different architecture than this one. That is something I will talk about later on. And I found it important to add it to the PowerPoint, okay? Because companies are more, as time moves on, a lot of companies are using Flex ASM and Flex Cluster. So I will throw more light on it when we get there. So this architecture is a typical architecture of a Chuno rack. Typical configuration. Most of the company will have this configuration. So this is a 2 node rack. If I have 4 node racks, just multiply it by 4, right? You guys can see that there's no difference at the node level. All of them have the same information, right? So if I add nodes, if I add servers, it doesn't matter. Sorry, I use a word node. Maybe it's new to you guys, right? Because we never heard of node before. So if I'm saying node, consider it as server. A node is a server. So in rack, we use the word node. We don't talk about servers in rack. If I talk about node 1, it means that it's a server 1. Does it make sense? So server 1 will be like student 100, and server 2 will be like student 200. Does it make sense? So consider node as servers. A node is a server, no difference. The difference is that in rack, we instead of calling them servers, we call them nodes. Does it make sense? That's what it's all about. So what you can see here, what is familiar to you when you guys see this picture? Just tell me what you on this architecture. What looks familiar? What have you ever seen before?
Database instance.
Okay.
Local listener.
Okay. What else?
Database home.
Correct. Database home.
User data files, undo table space, control files, SP file, password file, database home.
Yeah. Okay. I will talk about, okay. Don't get surprised you see database home, not recommended. This one just means that the database home is shared. I will talk about it later on. And the benefits and disadvantages of it when you are talking about rack patching. Yes. Okay. What looks different? What looks new to you? What have you ever, okay, before this topic, right? What looks new?
Scan listener.
Correct.
VIP, ASM. Oh, not so much ASM, but
Dynamic service.
Correct.
Vote files.
yeah, the ORC vote file.
Vote file.
So node X and node Y, it's also new.
The two different nodes.
Undo
Then the
table.
scan.
What is scan up there?
Very good. Scan.
Scan.
Okay. What else?
Undo table space per instance.
Undo table space per instance. At least you guys know what are undo table spaces, right? Even though here they just put per instance, right? But at least you know undo table spaces, right?
Yes.
Then the interconnect.
Interconnect. All right. So yes, those are
We do
new.
G.
No, it's Zillow group. Zillow group.
Okay.
Yeah. Two Zillow group per instance. That means each instance has two Zillow group. Okay. All right. So good. That is what makes the difference between rack and single instance. Remember, I said that in rack, multiple instances communicate. Let me take an example if they don't communicate. What will happen if they don't communicate? Let's see the disaster. This issue is what we were facing on 9i. And we call this issue gist pinging. We have two instances. Let's assume they are not communicating. Instance 2, instance 1, both are sharing the same database. That means they have the access to the same storage. Now, hey guys, let's see the logic, okay? I want it to make sense. Instance, we have a table at the disk level, and we have an employee called A, and the salary of the employee is $2,000. Okay, that is the end of the year. The guy did a good job, and we decided to increase the salary of this employee. Add the salary, right? We have a percentage, certain calculation. And when the calculation is done, we have to run a SQL statement to update the salary of the employee, right? Let's assume we have to move from 2,000 to 2,100. Okay? So that means, let's assume when you launch your code, Rack redirects you here on instance 1. So it means that on instance 1, the salary will be changed from 2,000 to 2,100. And you even commit it. Once you commit it, you know, okay, it will go, the Odoo will go to the Odoo files. But the GB writer has not yet written, you know, the block to the disk, because the GB writer will write in batches, correct? So you wait until you reach a certain number of blocks and you write it to the disk. Does that make sense? So let's assume this change is still on instance 1. Now, we say 8, the percentage is not good. There was a slight mistake somewhere. 2,100 is too much for this guy. This percentage was for something else, for someone else who did a better job. Instead, the salary has to grow to $2,050 instead. You run another job, and it comes to instance 2 instead. Okay? And now it's $2,050. And we also committed. The previous transaction was still on the memory on instance 1. And on instance 2, the new transaction is still on the memory, right? At some point, the DB writer on each instance will have to write the data to the disk. What will happen? Instance 1 will try to write 2,100, and instance 2 will try to write $2,050. Confusion. and that will cause data corruption because two different records are going to the disk. Instance 2 is not aware of what is happening on instance 1. Instance 2 will just go to the disk and get the data there and update it as well on its memory. So we can see here that we can see the problem here, communication issues. Now, on starting from 10G onward, we came with the interconnect that will allow the communication so that if instance 1 was the one to update the block, instance 2 can know where the most recent copy of the block is. If the most recent copy of the block is on instance 1, instance 2 will be able to request for the latest copy from instance 1, right? And get it from there directly. So that means instead of going to the disk and getting the old copy that was $2,000, instance 2 will be able to ask to instance 1 to send the latest block, and the latest block will be sent to instance 2, and instance 2 can update it without having to go to the disk, if that was the latest block or the most recent one. I don't know if it makes sense what I just said.
Please, I have a question. So you said that instance 1, he did not commit?
No, he committed.
He committed. Okay. But then this instance 2, they did not select to view what the committed, what the new total was, right?
Even if I did not have this configuration I put in red, right?
Yeah.
Even if instance 2 selects, instance 2 will see the old copy that was on the disk, especially if instance 1 has not yet reached the block to the disk.
Okay.
They'll be working independently. Instance 2 won't be able to know the change that just occurred on instance 1. So if I do select, I just go and get the latest copy from the disk. And the disk is older, right, than what just happened on instance 1.
Mm-hmm.
And that was the issue we were facing before. But now, from 10G onward, we can have the communication between instances, and one instance can know what's happening on another instance.
Mr. Gaetan?
Yes, Mr. Allen.
Meaning if on instance 1, meaning if the change is done on instance 2 much later when the information is already written on disk, we won't have that problem, right?
Yes, if the information was already written to the disk, you won't have that problem. Instance 2 can just go to the disk and get it.
Okay, thank you.
All right, welcome.
So
yes, go ahead, Mr. Kuti.
Okay. The two instances or the two nodes, do they share the same data file?
Of course. You can see they share the same data file. They share some files, right? Share the same system user files. Okay, they share the same control file, but there are some stuff they don't share. The undo table speed they don't share the redo log. They share the same data file, the same control file, the same SP file, password file.
So what I was thinking was the statement I made earlier, like one server controlling or managing the different nodes or the two databases.
There's no two database, there's one database.
I'm seeing node X and node Y. You see the one database?
Two servers, two instances. Each instance running on each server. The database is running on the database is stored on a different server. So this node X is a server, this node Y is a server, and this storage is somewhere else.
Okay. I was confusing this storage to be a server.
This storage is also stored on a storage server. You guys saw a message from Prof about your servers. He said the SAN storage has an issue, right? Because that's where the data is. I told you guys earlier that when you guys see ORA data, when you do GF minus H, you see slash ORA data. It doesn't mean that that space is allocated to that server. It's just a mapping. There's a relationship between two servers behind the scene. Something happened behind. So that means we have a database server, we have a storage server. So what happened is that we just map, you know, the storage with the database server. You can see the storage from the database server. Okay, so this storage is somewhere else, on a different storage. Okay, this database is on a different storage server. Okay, so it doesn't have any relationship with this other.
So, sir, therefore, the two servers they share the same data files.
They share the same data file, yeah.
That's interesting. Okay, thank you.
Welcome. They share the same data file. Question? Okay. Okay, what I was saying was that you know, just based on this example, just for you to see that now we want those servers to communicate. Okay, so what will happen, what we call this communication, what we take of the communication. Okay, because we have a new setup, we want them to communicate. What we allow this communication. That means what? In addition to what you guys know, there is something we have to install for all this to happen. On top of what you guys know, right? You guys learned before, there's something additional that has to be installed for this communication, this collaboration to happen. Also, the collaboration at the storage level. Imagine two people sharing the same data, two instances sharing the same data. That means someone has to coordinate that, to keep track of that. So it means that there's an additional setup that has to be performed. And that's what you guys will configure. We call it the grid infrastructure. So you guys know the Oracle software. In addition to the Oracle software you guys have been installing multiple times here in Brontech, you guys will learn how to install the grid infrastructure. That grid infrastructure is actually what allows the multiple instances to communicate, and also how to, you know, to monitor instances accessing the data file or the data or the storage. That is the addition. That is what comes in addition to what you guys learned so far till now. That is what makes RAC a bit different. That's what we bring new command, and that's why we bring new component you guys have to learn. The grid infrastructure. The grid infrastructure is made up of two main components. The first main component is the clusterware. And the second component is the automatic storage management, ASM. The first component, which is the clusterware, is actually what allows the node or the instances to communicate, to behave as one buffer cache or one instance. So from outside, the customer will not know that we have two nodes behind the scene because they are behaving as one. So that software that is called the clusterware will allow that communication. If instance 1 is looking for a block, the most recent copy of a block, and that recent copy is stored on instance 2, instance 1 can request for that. And instance 2 will send that copy to instance 1. Instead of instance 1 having to go to the disk again You guys know that whenever you go to the disk, we call it a cache miss. And a cache miss is more expensive than a cache hit. So it means that if I'm able to get the latest copy of a block from another instance, it means that I will have a better performance. I will have the execution time will reduce. Now, what we allow that communication between instances is what we call the clusterware. And what? Instance 1 and instance 2 share the same storage data file. How will I coordinate whenever one of them has to go to the disk? How will I tell instance 1 where the block is located? We have the second component called the Automatic Storage Management, ASM. The ASM is located on each node. And this ASM is the volume manager. It's actually what manages the storage. Now, moving forward, we have somebody who is managing the storage for you. The server process, we no longer just move from the instance and just go to the data file and get the block and move to the instance with that. Before any process goes to the disk, they have to contact the ASM first. The ASM instance will tell you where the block is located before you can go to the disk and get it. Because the ASM actually knows how the data is organized at the storage level. And that ASM comes with the grid infrastructure software that you'll be installing. Okay, so these are the two key components you should be able to talk about. Clusterware to manage communication between instances, and ASM to manage communication at the storage level. How to monitor the storage. How to organize the data at the storage level, the ASM takes care of that. How to detect the corrupted data and how to remove the corrupted disks if it has to affect others. The ASM takes care of that. And it is done automatically. That is why the name is Automatic Storage Management. Okay?
Yes, sir.
Yes, sir.
Yes, sir.
Great. So, you guys will see all that description somewhere below here. Okay? Clusterware, ASM, and so on. Okay? So, clusterware to manage the instances. It is like any software. The Oracle software have some critical files. Or the Oracle database, let's just take the Oracle database, right? Has some critical files. Without those files, the database instance will never be, the database won't be open, can't be open. Some of the you guys know are the SP file or the P file, right? If you don't have parameter file, you can't start the database.
Mm-hmm.
Control file, you cannot mount the database. You don't have the data files, you cannot open the database. That is how important those files are, right? Learn that. Now, the clusterware as well comes with some critical configuration files. And today, before I close this session, we talk about one of the most important files in the entire RAC environment that everybody should know. This is the file you guys see here. The OCR, also called Oracle, is Oracle Clusterware Registry, something like that. Let me see. No, somewhere. Oracle Cluster Registry, okay? Oracle Cluster Registry. So this one is one of the most critical files in RAC. Without this file, the clusterware will never start. The clusterware cannot run. It's like the control file of the clusterware, the brain of the clusterware. Without the OCR, if the OCR, which is a file, is corrupted, or we don't have a backup of this OCR, the clusterware goes down. Whenever the clusterware goes down, it means that there's no communication between instances. Instance 1 will no longer know what's happening on instance 2. And most of the time, it can also bring down the database instance along with that. So the OCR, Oracle Cluster Registry, it stores all the clusterware related details. The number of nodes, the number of virtual IP address, I'll talk about all those stuff, right? Network, the number of listeners, and so on, the number of scan, all this information are stored in the Oracle Cluster Registry. It's like for Oracle, right? Everything is stored in the control file. All the architecture is stored in the control file. So in the grid infrastructure, all those details are stored in the OCR. So that OCR is the key for the clusterware to run. Okay, so that's why we make sure that we have multiple copies of the OCR to ensure high availability. That's what we do. We should know where the OCR is located, and we should know how to protect it. We should know how to back it up. Because without the OCR, the clusterware won't be able to start. The OCR fails, everything fails.
If it fails, is it possible to create another one or to copy?
If you have a copy, you can. That's why you need a backup.
Okay.
You have a backup, you can recreate it using the backup. Without backup, you just lost your RAC.
And what does implement if you lost your rack in a real environment company?
If you lost your RAC, that means you have to reconfigure it, right? You may just rely on your backups to reconstruct it. If you have some backups available, first of all, they will have downtime, because whenever the clusterware is not available, the OCR is lost, everything, all the nodes won't be accessible. So it means that downtime at the application level. And I have to tell you guys this. If the ASM is down, the database instance will also go down. So whenever those components of the grid infrastructure, they go down, it affects the database instance as well. So if the ASM goes down, the database instance goes down. It means that there's outage. So your job now will be how to fix that. Troubleshoot.
So I have a question.
Oracle support and someone for Oracle support, if they can help, they will ask you the type of logs you have to collect, and they will see if they can help. If they cannot, they will give you a solution on how to rebuild it from scratch. Yes.
Um, we know that RAG is for a company with service level agreement of zero downtime, and if we still have to encounter downtime with RAG, is it that necessary to like to have RAG?
It's not really for the entire company with a service level agreement of zero downtime.
Okay.
Applications. Companies have multiple applications.
Okay.
And application are classified, we have different levels. So we talk about tier 1, tier 2, tier 3, tier 4. Just to summarize, if I talk about a tier 1 application, it's a mission critical application. It means that that application cannot afford a certain amount of downtime. So that is the application that cannot allow a certain amount of downtime, not the entire company. Because we have some applications that can be down, okay? That are not running 24/7. In a company, that not all applications need to run 24/7.
Okay.
Let's say if I take an application for transport, okay? If maybe you have a transport, at some point it stopped at midnight somewhere, right? We no longer have customers maybe for the transit, right? So from midnight till the morning is not useful. So it can be down. But if an application maybe for sales, like people can buy stuff online 24/7 around the globe, then in that scenario, it's mission critical because it should be up 24/7. So the SLA is at the application level. Don't talk about it globally for an entire company because they have application classified. They classify the application depending on how critical they are.
Okay.
Does it make sense what I just said?
It does, sir.
So if they are buying RAG, it's because of those applications, mission critical applications. Those applications that cannot afford a certain amount of downtime, then RAG is used for them. Those other ones that don't need, that can be down for any reason, we can just rely on our regular backup. It's like DataGuard. DataGuard is not configured on all databases. You will get an environment of 100 databases, you will see DataGuard configured only on 2. If you see DataGuard configured on a database, you should know that the database is a very important database. If you see RAG configured on a database, you should know that database is a very important database. The application running on it is also very important. Okay, so the service level agreement is at the application level. Don't say the company level. Okay.
Okay, sir.
Okay, sir, I have a question. So this OCR, is it a binary file as well? Like
it's binary file like the
SPC?
control file. You cannot read it. You cannot understand what is inside. Okay.
Okay.
Open it, you won't understand what's inside. The OCR itself is located on the shared storage, right? But its backup is not on the shared storage. Whenever you back it up, it is stored in one of the nodes. And I'll talk about it later. Backup of the OCR, how it helps, master node and so on. That's something else.
So you cannot edit it or anything? No, okay.
You cannot. Maybe Oracle can do that, but I've never seen someone editing the OCR, right? Never. Any other question? We are done for today. This is where I had to stop. Any other question for me?
Yes, I have a quick question.
Sure, Mr. Koji, go ahead.
So who allocate memory to ASM? Because it's like it's automatic.
It's part of what we call prerequisite when you have to install a software. Like I did for Golden Gate, right? We also have some prerequisites for RAG. I said for Golden Gate, you need a certain amount of memory, certain amount of CPU, certain amount of, okay? I gave some prerequisites, right? Before you guys install Golden Gate. So even for RAG, when Oracle is providing a README file to install RAG, you should go through that README file and try to make sure that you met all those prerequisites. Now, depending on the load on the application, it will help you to determine the size of the database instance or the ASM instance. Does it make sense what I just said?
So you determine, like the database determine the size of
Not
the
you.
ASM.
Not you. Sometimes some application, the vendor already know how much memory you actually allocate to instances. Like like a spreadsheet, right? They already know when they are building their product. They say this application will work better on this type of storage and this amount of memory, minimum amount of memory. Most of the time you can have this information, but you, the GBA, are not the one to determine size. Okay, how much memory you actually allocate to the ASM or the database. Okay, it's something that is planned. They will just tell you to do that. You just follow what they are telling you to do. They just tell you install rack, configure with have this amount of this group and so on. You just do it. You just follow. Okay, and because the rack configuration is a teamwork, definitely you'll be working on it together. Okay, so definitely that's how it will be. So you'll be working on it as a team. Okay.
Okay.
Yeah. So because you guys cannot install rack from scratch yourself, that's why I want you guys to watch that video, because the initial stage of it is not your job. I give you a server to build it from scratch. It will be difficult. You may need a lot of time to do that. You will not even do that because some of the activities performed are not GPA jobs activities. So that's why that video is a 4-hour video. I will show you guys where it's located, and you can see what the sysadmin does. I'll use the same video. I will install rack, but the rack 12C. Anyway, my assignment will be rack 12C, not rack 11G, because that video is rack 11G. But I will change it and I will make it 12C so that you guys don't do anything on 11G. Yeah.
Sir.
Yeah.
Oh no, go ahead.
Yes, that's it. I'm done.
Okay.
Yes, sir. Yes, sir.
Baka, when I ask my question.
Shut up! You don't ask.
Go ahead.
Go ahead.
Go ahead, Baka.
Yeah, Mr. Gaita. So my question is like, if the OCR goes is corrupt, basically Node X and Node Y, they're gonna be down, right?
The cluster will fail. Yes, the cluster will not. The node is a server, right? But the cluster we're running will fail.
Okay.
All the cluster where component will fail, will go down. Yes.
Okay. All right.
Till you fix it. So that is why, in order for us to avoid single point of failure, we will have multiple copies of the OCR. We have redundant copies, at least 2 copies, so that if one copy is corrupted, rack can use the other one. Does it make sense?
Yes, sir.
So how about when it comes to the listener? Do they listen to one listener or?
Very good question. We now have multiple listeners. We have local listener, we have remote listener. The listener now is no longer a listener dedicated to a particular node. The instance the listener is a global listener now. So the listener can listen to multiple instances at a time.
Wow.
So the listener now is at the grid infrastructure level. It's no longer at the database level. You guys know that whenever you install Oracle software, it always comes with the network admin directory, right? And that is where you guys configure the listener.ora file, right?
Yes.
It's dedicated to that particular software. And here now, the listener at the level of grid infrastructure. So if you want to monitor the listener, you should be at the grid infrastructure level. And because the grid infrastructure is at the cluster where monitors multiple nodes at a time, that means the listener is also available for multiple nodes at a time.
Oh.
So it's more global. Yeah.
So if that listener is not up, so that means the nodes will not be running, or?
The listener doesn't affect the node. The listener only affects people who are trying to connect to that node.
Okay.
The listener down means you cannot connect to the node as a customer, as a client. Application team need to connect using listener and port. Connection strings. How if you are an application user, you don't have the listener port, the protocol, the host, and the service name, you won't be able to connect. You GBA are able to connect because you are 6DBA, you are connect at Oracle, you are administrator. That's why you guys never face listener issues. But as a customer, you will have listener issues, you will never connect. A few example of listener issue you guys face was using Arman duplicate. Because Arman was behaving as a client. Arman has to connect to the remote database. And in order for Arman to connect to the remote database, the database has to be listened. So without the listener, client cannot connect to databases. But you, GBA, you can connect. Okay?
Yes, sir.
Question?
Yes, sir. Let me ask my last question. So not to move ahead of time. I stumbled upon one interview question where that is the lady testified that she has managed terabytes of databases, and the interviewer asked her, so if you've handled terabytes of databases, what amount of memory did you allocate to ASM? That's why I was wondering if is database administrators that allocate memory to ASM, or is done automatically?
No, you have to add memory, right? Okay, terabyte of data and amount of memory, right?
Yeah.
Okay, the database terabyte and asking how much memory. It depends, okay? You will find yourself increasing the memory depending on what you observe, right? If you are having performance issues due to small memory, and after analysis of your AWR report, you may find yourself increasing memory. Let's assume that every time I notice that I'm having a huge number of cache misses. This is a small example. Cache miss just means that every time I'm going to the disk because I have a small memory. Okay. After root cause analysis, you will see that okay, this huge number of cache misses is due to the size of the memory. I may need to increase it. That's not a decision you make, right? You raise a request and someone has to approve. The application team has to approve your request because you are just there to monitor the database, but they are the one to own the database. So before you do anything, they should approve. They may ask you to do that, okay, if they find it useful, right? But for you, you don't just wake up in the morning, you just set up a certain amount of memory. No, it depends. Nobody should tell you that for this amount of disk, there's a formula exactly to this for this amount of memory. It doesn't work like that. Depending on the impact. If the environment is busy, you may have a different result. If it's not busy, you may have a different result. Okay, so that question totally depends on the environment and the type of application. Okay?
Okay.
So those people, right, when they ask you questions, sometimes they just want to know whether you work or not. Sometimes they ask questions that do not have an answer. And because us, we want to find answer wherever we don't have answers, we will try to okay? So sometimes that's what they like doing. They ask you impossible questions that do not exist. Someone asked me in an interview one day, how many processes we have in Oracle?
Oh my God.
I told him I don't know. And at the end of the interview, I asked him, how many processes do we have? The guy could not ask me answer. You ask me a question that you cannot answer.
No.
So that's how some people are. They want to just to see how stupid we are, right? And that's it.
So how many processes are there?
I don't know. Even till now, I don't know.
Anita, are you kidding?
I'm serious.
Only Rack his own have a lot of like processes. Data
know.
his own processes. How you? I mean, there's a lot.
So, sir, if you claim if you claim you've managed terabytes of databases and question like that post up, how are we going to defend ourselves?
Definitely, someone who manages terabyte databases is an expert.
Right.
It's difficult. They like people like that. It's a data warehouse, definitely. That means you have an experience because whenever you are dealing with something bigger, you have more issues, performance related, backup related issues, and so on.
So I have a question. In this case, do we give names like same names to nodes, and I don't know how it works when
Nodes are servers. They have names.
Okay.
Student 100, another one can be student 200.
All right.
They work exactly the way you know. What you know is okay. They have names, they have and so on. Okay. So, okay, guys, I'm 2 minutes late. Okay, from my regular daily meeting. Any question, please? We push it to Friday. Okay, we have a short session. Okay, so good night and see you Friday. Thank you for your attendance.
You know, go show us the video. Where is it located?
Next class. Okay.
Thank
No,
you.
the people take you. Tell me, Bretta.
Next class. Don't worry. Next class. I have to log into Canvas now.
No, Fale, any question, ask me.
He said it's in Canvas, so
I will show you. It's in Canvas, but if you want, I will show you.
Go show us. That's mean like some place you can also maybe some.
Yeah, I will show you guys, please.
No worries, no hurry, don't hurry. No sit.
Oh, that's why I was in my question.
Hidden.
I don't want to discuss for this one.
Okay.
You're gonna see it. Don't hurry.
Grandbaka says you should ask him his database.
Okay, Grandbaka, I'll go ask you about it.
Yeah, his database
I will log out. You guys can stay. You want to? Okay. So, all right. Good night, guys.
Okay.
Thank you, Gata.
Thanks.
You guys can ask me. I'll show you. I'll show you where it's located.
Officer,
okay, thank you guys. Excuse me.
Enforcement officer.
Excuse me, coach. I got a question. I got a question. Another. Funny. It's funny. Yeah. I want to say something, Renata. Not take it too bad if I say this one. Because you know, when you lead there, you lead in class, you lead in some people, some group, you have to do something like you come back. If you do some project to the people, you need to come back, give you the people the feedback. That is very, very important. You go be leader one day in a company, one day in some place, you need to come back, give you people the feedback. Maybe you use the top. I work in the army, sometimes I feel like the general be the most important people, but it's come back to talk to you like a human being. I don't appreciate last time Patrick called you to join us because we got some question. You say you will come back, but you go, we wait for you, you know, come back. I don't know if you send the party the message later, but if you cannot come back, because everybody got occupation, everybody's busy, maybe send a message, hey guys, sorry, I cannot come back because I'm busy. Because you cannot treat people like it's the key. Okay, I'm okay.
But Fali, let me jump quick before she jumps. I don't know if you were in the group where I shared that she contacted me and she excused herself. I don't know if you were not there, but she contacted me back and then she excused herself and I shared with the group. Go ahead.
Okay, but I said that time was waiting for her. I know she's busy. She cannot come. She cannot come in, talk to me, talk to people. I know that's the freedom. But when you lead there, if people waiting for you, if you cannot come back, at the time you say, "Hey guys, can you do whatever you want to do? I don't have time to be there because I'm busy." It's okay, but you cannot leave people. Maybe come back next day or later on. But if you do something, we not come back, you just ask you guys a question, hey, what's going on? This is equal fundamental. If you guys don't have idea, somebody can have a better idea It brings to you guys, hey guys, that's why I think about the way we can do the things is better. You come back, giving people the feedback. We cannot just come in to ask, hey, what's going on? That's what I want to say.
Sally, I heard what you said. About last time, I'm so sorry about what happened. I was unfortunately so busy and I could not make it. And unfortunately, I did not let you guys know. Um, I believe everyone has been waiting for feedback, and for some reason, I haven't been able to make it in the past classes till the end. So for those who are concerned about it, the SQL fundamental we are supposed to do. I am still waiting for the morning class. I think I contacted few of you guys, and for the fact that the morning class are not yet able so far. From what I know, they are not yet able to pick up some dates for due to the fact that most of them work in the night, and to be able to take it, they must have people along with them. So they haven't yet come up with it. So my question was, because what I had in mind was that we could take it at the end. That means after, since there are four of them, we could take it after them. But if you guys are in a haste, and that means if you guys feel like no, you want to take it now and whatsoever, we could schedule our own before them and we just take it. Because I believe for now we don't have any reliable dump file. Apparently there's one out, but no one has confirmed it. So if you guys feel like you're in a haste, we can take it before them. If not, we keep what we have in mind, that we take it after them. I believe after them it is gonna be more more reliable, more sure, because 1, 2, 3, 4 people has taken it already. We have taken it already. So that's what I had to tell you guys. Now it is up to you.
Renata, thank you so much for bringing this one back. Because for me, my problem is not taking one now, not taking back, because we need to know. You guys do some organization for the SQL fundamental. We need to know what's going on. We can go forward. What's going on? We got some issue. We need to put more money. We don't need to put more money. That's the point. Hey, people don't have time. We need to change the people. We need to make new profile. That's why the communication is very, very important in organization everywhere. That's what's my point. That's it.
Okay, I get what you're saying. As for now, there's no real problem. The only problem is the availability of each and every one. That's the only thing. Apart from that, there's no issue. As I was saying, I am waiting for morning class to let me know how they've done. If they've chosen the date, if they've done whatever they want to do. If you guys want us to take it in the beginning or in the end, however, it works for me.
Okay, thank you.
No problem. Okay, apart from that, I believe there's nothing else. If anyone has, I saw a message, Natu shared in the group. I don't know if it's coming from Prof or, but whenever you guys are coming with your, with those issues, please, you guys should mention if it is for a new server or if it is for the class, the Golden Gate class that Ethan wants to take. So apart from that, if no one has anything else, we can stop. Yes. Let me see.
Oh no, Jesus Christ.
Okay, you guys have a good night. I'll end the meeting.
All right, good night, everyone.
Yeah.